Okay, we'll look at this bilging theory problem now, where an empty midship compartment affects the draft and may also result in a change in the vessel's intact waterspan area. Identify and explain a possible scenario, including incorporating a watertight flat, if appropriate, where such bilging could result in an increase or reduction in the vessel's GM. So I'm going to look at three situations. In this first situation, with no watertight flat, now remember that the kg remains constant. So working out our initial GM, it's simply half the draft plus BMLB cubed over 12, nothing changing initially, we get 11.26 on the values I've written up here. Then the final KM, we get our sinkage and our new draft, and of course the KB in this situation, because there's no flat, is simply half the new draft. The BM, because we've lost that midsection, that 20, the L becomes 100 instead of 120. So from 120 it drops to 100. Therefore the BM drops from 8.01 to 6.68. So although our KB has increased slightly, the BM is decreased, and therefore our final KM of 10.58 results in a decrease of the GM. So in that situation we get a decrease. Now I'm going to use the same dimensions, but I'm now going to introduce a watertight flat. So again, kg constant, so the initial km is the same, 11.26. So in each of the problems, our initial km isn't going to change for purposes of an explanation. The final km, obviously we get the sinkage and the final draft, and then of course because we've got the flat, our KB has to be worked out using volume and moments, and we get a KB of 3.65. Now the BM, because we are bilged below the watertight flat, the length hasn't changed. Therefore for the BM we get 8.01, KB 3.65, KM 11.66. So in this instance we get an increase in GM when we're bilged below the watertight flat. So mathematically that's showing you bilged below, we can actually get an increase in the GM, and that's based upon really the BM where we use the full length. Now in this example here we're going to be bilged above the flat, so our length is going to be compromised. Obviously the kg is still 11.26. Final KM, get the final draft, the normal procedure. KB again, the volume and the moments we have to use. But where it changes again, of course, is the BM has to be 100 by 25 cube, not 120. So it gives us a final KM of 10.12, and of course in this instance we have a decrease in GM. So that's the three examples I've used to show you how the GM can change, increase or decrease when we're bilged. Part B talks about with an empty midship side compartment will negatively affect a vessel stability. So this is now a side compartment and we get listed. Explain with the aid of a sketch how the cross flooding can restore some of this loss. So there's a vessel with side bilging, and we have a list moment curve. So this is the original curve and then the new curve, and all we're left with is the stability there. So when it comes to cross flooding, of course, we can reduce the listing moments curve. So that will help, but it won't completely rectify the situation, because of course we've got this reduced angle of deck edge immersion due to the reduction in the freeboard. So there will be an improvement due to us altering our listing moment curve when we do what it says in there, when we do the cross flooding. So that would be the sketch, and then you just discuss about that and maybe draw another listing curve on to explain as well.